A percent compares two quantities. One is going to be the whole, and the other is the part, which is very similar to a fraction. The whole is going to be the denominator, and the part is the numerator. So if you share a candy bar with two friends, then you're going to cut the candy bar equally into three parts. So the three parts make the whole candy bar. And each of you is going to get one part out of those three. So 1/3 of the candy bar is what each person gets. That's 0.33333, or 33.333, repeating, percent of the bar. That's what each friend gets. If you cut a plank of wood into fifths, and you're going to use two of them, you've used 2 parts out of the total, the 5 whole parts that make up the plank. So in other words, it's going to be 0.4, or 40% of the plank has been used. Now, before we can study general applications, it's going to be helpful to just study these simple forms, these simple translations from English to mathematics, because we can take any general application problem for percents, convert it into this statement, and then that's very easy to convert into the mathematics. There are, of course, a couple things you should keep in mind. First off, percents are never used in equations. You will only ever use decimals in there. So you're going to want to change the percent to a decimal first. Percent is more of a term we use to interpret the meaning of the decimal. The unknown quantity x is going to be shown really with the word what. That's how you typically see that in the English question. Of in this statement means multiplication. Now, sometimes the word of in English is just used because you need to use the word of. But typically, if you see the word of with mathematics, that means multiplication. We always multiply the percent and the whole. You never multiply the percent and the part. That's not how percents work. Is an equal sign. That's what that means. Now, the percent and the part are the same quantity. That's why you never multiply the percent and the part. The percent is just a different way of thinking about the part, and the percent is in reference to the whole. Because the percent and the part are the same quantity, you're going to see them on either side of the equal sign. So you should have percentage equals the part, and then you're actually going to have the percent times the whole here. That's how these statements are always going to turn out. The word whole can also be referred to as the total or the base, but in a lot of different contexts, the starting amount will also be a valid term for what the whole quantity is represented by. And this will make more sense when we talk about applications. So we're going to determine the missing quantity and round to 2 places as necessary. What is 12% of 20? Well, what is going to be x? Is equals 12% is 12% as a decimal of multiplication 20 can be 20. What we found here is this is the percent. The percent always multiplies the whole, and x is going to be the part. So 12% of 20 is going to be the part. If we do that on a calculator, is 2.4. So 2.4 is 12% of 20. 30.45% of 450 is what number? So 0.3045 of 450 is what number? 137.025 equals our unknown. So 137.025 is 30.45% of 450. Okay, 34% of 600 is what number? 204. 204 is 34% of 600. Okay, what number is 0.5, be 0.005 of 8? So we're talking about a very small percentage, so we expect this number to be very small. Okay, 0.005 times 8 gives me 0.04. 0.04 is 0.5% of 8. Okay, 200%, that's going to be 2.0, right? 2 spaces, so it's just going to be 2 of 55 is what number? Now note 200% is above 100%. So actually, this number is going to be bigger than our whole. 55 is the whole, but 200% of 55 is actually going to be 2 times 55, which is 110. So in this case, the part, quote unquote part, that's why it was in quotations, 110 is actually bigger than the whole. The same thing is going to happen here. 807%, this is bigger than 100%, so we're going to expect a bigger number than this one. What number is 807% or 8.07 of 201,233? 1,623,950 and 31. Okay, now for these 6 cases that I've shown here, I've shown how to solve for the part when you know the percentage and the whole. For all of these things, you can actually check your answer to make sure it's correct by just taking the part and dividing it by the whole. And if you do this on a calculator, you should get that percentage as a decimal. 2.4 divided by 20 gives me 0.12. This is the percentage as a decimal. So you can always kind of check your work that way. Now for these next ones, we're actually going to be solving for either the whole or the percentage. And for this, we have to solve the algebraic equation. In the previous ones, right, we didn't have to solve for x because x was already by itself in all of these cases. For these ones, we can say here for this one, 60% of what number is 15? 60% of what number is 15? We need to get x by itself to solve for it. To do that, we're going to divide by the number multiplying x. So x is going to be 15 over 0.6, or in other words, 15 divided by 0.6, I get 25. So what I found here is that the whole, right, because the whole always multiplies the percent. 25, 60% of 25 is 15. 15 is the part, 15 is 60%, and it's 60% of the whole. 15 divided by 25 gives us 0.6 or 60%. Okay, for this one, 25 is 0.1225 or 12.25% of what whole, right? You're always multiplying the percent and the whole. We need to divide. That's going to give us 25 divided by 0.1225 is 204.08, and it actually continues on. So you probably want to round this number. Approximately 204 is the whole. 175% of what number is this? So 1.75 of what number is 325.16 divided by 175. This one actually continues indefinitely. I think it repeats. So what I have here is I have 175%, right? This is a bigger than 100%. And if we're going to multiply a number bigger than 100%, the whole is actually going to be smaller than the part. Typically, the part's always smaller than the whole. That's how we normally think of percents. But sometimes we can think about these cases when we are going above 100%, which does make sense in certain contexts. In a lot of them, it does not make any sense, though. Okay, 20 is 14 or 0.14% of what number? So I just need to divide. $14,285.1 or 71. This continues on. So very small number is the percentage, and 20 So it's going to be way bigger than 20. And that's what we see here is 14,000. So that kind of makes sense. Okay, 105 is 1515 of what number? Once again, I need to divide to get x by itself. Gives me 693 point, and this one actually repeats 0693. It actually repeats the 0693. 40% of what number is 20? Divide. X equals 50. 40% of 50 is 20. Okay, so for all of these 6 problems that I've gone through, I found the whole. And in some of them, right, the whole was smaller than the part. Most of them, the whole is bigger than the part because we typically think about percentages being less than 100%. Now, for these, we're going to solve for the percent. And still the same kind of setup, right? What percent, that's now our x, of 140 is 3.8. To solve this, we just need to divide by 140. We get x equal to 3.8 over 140, which is 0.02714, and it continues. Or in other words, it's going to be 2.714%. Okay, for this one, you can see that we're trying to find the percentage, and so that's going to be our x. And we have the whole, right, of 140. This is going to be the whole, and 3.8 is the part. So you can, of course, write this equation out like this. All of these work out that way. You can also just take the part divided by the whole, and then change that to a percentage. That's a quick way. If you're trying to find a percent, you can just do that. You don't have to go through this process. Either way you do it, you will get the same answer. So what percent of 620 is 136.4? To solve this, I have to divide by the 620. And doing this, it actually gives me the part divided by the whole. 0.22 or 22%. And we want to write this as a percent since we're asking what percent is this. Okay, 0.05 is what percent of 25? I could also just go 0.05 divided by 25 because I know 0.05 is the part and 25 is the whole. So we're going to get 0.05 divided by 25. It gives me 0.002 or 0.2%. Very small amount. 0.05 is very small compared to 25, so we expect the percentage to be very small. Okay, 240 is what percent of 100? Divide by 100. We get x equal to 240 is bigger than 100, right? The part is bigger than the whole. So we expect a percentage bigger than 100. 240 divided by 100 is 2.4, which is the same thing as 240%. And this is an important one to see here. You can see that we had 240 of 100. 240 became 240%. That's because 100, a percentage is always based out of 100. So whenever you're referencing what percent of 100, then the number is the same thing as the percentage. If I said 50 is what percent of 100, it'd be 50%. If I said 8 is what percent of 100, it'd be 8%. 1,000 is what percent of 100, 1,000%. That's how it always works because percentage is always out of 100. Okay, the last two, what percent of 12 is 8? The part is smaller than the whole. So we're going to expect a number less than 100. 8 twelfths is the same thing as 2/3, which is going to be 0.6 repeating, or 66.67%. percent if you were to round up to two places. Finally, we have 105 is what percent of 123? 123 is the whole, 105 is the part, so we need to divide by the whole. It gives us 0.853, and this actually is going to repeat. So 85.3, it continues on indefinitely. That's the percentage.